So the first thing that we're going to be focusing on is the idea of solving the inequalities. So we're looking here at this following statement where I say 12 is greater than negative 8. This is a true statement. 12 is greater than negative 8, right? Positives are always greater than negatives. If I were to go ahead and multiply both sides by a positive 2, I would still get a true statement. 24 is greater than negative 16. This is still a true statement. But if instead of multiplying by a positive 2, I decided to multiply by a negative 2, okay, 12 is greater than negative 8. I multiply both values by a negative 2. I now have negative 24 and positive 16. Is negative 24 greater than positive 16? No. So this creates a false statement. The reason that it's creating a false statement is because of the fact that you are multiplying by a negative 2 instead of a positive 2. So whenever you multiply by a negative, that's going to cause you to have to flip your inequality in order for your statement to become true. Okay, so let's write that down. If you multiply by a negative, then you have to flip just the inequality symbol. Okay, the inequality symbol has to be flipped backward. Okay, so not the whole entire, it's not like a rewrite. It's not where we flip everything. You are only going to be flipping that inequality symbol in order to create a true statement. So that greater than symbol now becomes a less than symbol, and this becomes a true statement. Negative 24 is less than positive 16. Okay, so that's the only time that we are dealing with something a little bit different than when we are dealing with equations. Solving is all the same. This is just one little extra step of, hey, if you multiply both sides by a negative value while you're solving, then that's going to make you have to flip the inequality. It's also true if you are dividing by a negative value. Okay, if we divide by a positive, our inequality is going to stay the same. But if we divide by a negative, our inequality is going to have to flip. It's going to have to reverse. So multiplication and division by a negative is going to cause you to flip that inequality. All right, so again, if you are multiplying by a negative or dividing by a negative, you have to flip or reverse that inequality. And again, it's only by the negative. Multiplying or dividing both sides by positive isn't going to have any kind of effect. So let's go ahead and take a look at a couple of practice problems. Some of them are going to be one step, some of them are going to be two step, but it's the same process as when we were dealing with equations. Just don't forget that sometimes we do have to do rewrites if the variable is not on the correct side. So let's take a look. So for problem number 1, first thing that I always ask myself, is this at least written correctly? Do I need to do a rewrite? Yes or no? No, right? The variable is on the left side. Here's my inequality symbol, so I'm going to cover the inequality. My variable is on the left side of my finger. There's no variable on the right side. I'm okay with that. So we're good to go ahead and solve. So it is a one-step inequality that we are solving. We have x minus 7 is greater than or equal to negative 1. What inverse operation do we need to perform in order to get x by itself? Fahim? Addition. What are we going to add to both sides? 7. Very good. So we are going to add 7 to both sides. Again, guys, it's no different than if this said equals. If it said x minus 7 equals negative 1, you would add 7 to both sides in order to get the inequality by itself. So we have x is greater than or equal to a positive 6. X is greater than or equal to a positive 6. Now remember, if we were to graph that, it would be open or closed circle. Closed, right, because it's got the equal to sign, so I'd have a closed circle. Would it be going to the left or to the right? To the right. So it would be a closed circle, and it would graph itself to the right. Okay, let's take a look at problem number 2. For problem number 2, the first thing I ask myself is, do I need to do a rewrite? Do I need to rewrite this? Is the variable on the left side of the inequality? No, so I need to do a rewrite. So remember, when we rewrite, we flip the entire thing. The whole thing gets a mirror imaged. So we're going to have x plus 5. Our inequality is going to become less than, and then we have negative 20. X plus 5 is less than negative 20. Okay, what inverse operation do we need to do first? Io? Subtract 5. Good. So we're going to subtract 5 on both sides. That does get x all isolated. We do not need to do anything to the inequality because we only did subtraction. Subtraction does not change anything. Negative 20 minus the 5 does become a negative 25. Okay, is that an open or closed circle? Open. Is it to the left or to the right? To the left, right? The arrow's pointing to the left, so we would graph it to the left. Okay, so here's our answer. X is less than negative 25. That's what the graph would look like. Same thing for here. Okay, let's take a look at problem number 3. We have negative 3x is greater than or equal to negative 18. Do I need to do a rewrite? Yes or no? Here's my inequality. Is the variable on the left side? Yes. Do I need to rewrite then? No. If it's on the left side, you do not need to rewrite. Okay? You want the variable on the left, not on the right. So we don't need to do a rewrite yet. Okay? What inverse operation do I need to perform? Division. What am I going to divide both sides by? Negative 3. So here's the thing. I am doing a multiplication or a division. That means I need to ask myself, do I keep or flip the symbol? So am I going to keep the symbol or flip the symbol? Flip it. I'm going to flip it because I am dividing by a negative. I'm dividing by a negative. I need to flip. I am dividing by a negative. I need to flip. So it becomes less than or equal to. So x is less than or equal to positive 6. X is less than or equal to positive 6. Okay, I'm not going to bother with the open or closed circles anymore. I think you guys understand the idea of that. Okay, I'm going to do 2 more problems with you. I'm going to do two-step equation or two-step inequalities with you, and then you're going to do the rest of them on your own. So let's take a look at problem number 6, and we'll do number 7. So let's take a look at number 6. We do not need to rewrite because the variable's on the left side. So now let's just go ahead and start solving. What inverse operation needs to be performed first? Remember, we always do addition and subtraction first, multiplication and division second. So what inverse operation are we going to do? Subtraction. What are we subtracting from both sides? 14. We're going to subtract 14 from both sides. That's going to leave us with a 6x is greater than or equal to 6. Now what do I do? 6x is greater than or equal to 6. What are we going to do? Divide by 6. We're going to divide by 6 on both sides. I'm dividing by a positive. Since I am dividing by a positive, am I going to keep or flip? Keep. We're going to keep our inequality as is. It's not going to change. So we get x is greater than or equal to 1. Whenever you multiply or divide, you always want to ask yourself if you have to keep or flip. That's it. Okay, let's take a look at number 7. Number 7, I need to rewrite. I need to rewrite because the variable is on the wrong side. Jessica, you got to copy these down. Thank you. You need to rewrite because the variable's on the wrong side. So we're going to go ahead and flip everything. We're going to flip the whole thing because of the fact that we're going to be doing a rewrite. So we put x over -2 plus 4 on this side. Our inequality is going to flip. It becomes a less than symbol. And then we have -20. So we rewrote everything. Now we can solve. What is the first inverse that we need to do? Subtraction, right? We're going to subtract 4 from both sides. We're going to get x over -2 is is less than -24. Now what do we need to do? Last step for here, guys. Multiply. We need to multiply both sides by -2. And again, because I am multiplying by a negative on both sides. So am I going to keep or flip? Flip. We multiplied by a negative. We're going to flip this inequality. So the less than symbol becomes a greater than symbol. And we'll get x is greater than a positive 48. Okay, I want you guys to do problem 4, 5, 8, and 9 on your own. 4, 5, 8, and 9. Okay, let's go over this real quickly. Here for problem number 4, we have x over 7 is greater than -2. There is no need to rewrite. The inverse operation that we're going to perform is to multiply both sides by 7. Because of the fact that we are multiplying both sides by a positive, so we're multiplying by a positive, that means that we're going to go ahead and keep our inequality just as it is. Nothing's going to flip. Okay? So we're going to get x is now greater than -14. X is greater than -14. Okay, for problem number 5, I do need to do a rewrite because of the fact that I have my variable on the right side of the inequality. I want it on the left side. So we're going to go ahead and rewrite this entire thing. So that means -5x, and it becomes greater than and -15. Okay, we want the arrow still pointing at that -15. Then we can start solving. We're going to go ahead and divide both sides by -5. And so we are doing a division. We happen to be dividing by a negative value, which means we're going to go ahead and flip the inequality. So that inequality that was a greater than symbol is now going to go ahead and flip back to its less than symbol. Okay, so we now are going to get x is less than +3. Okay, when we take a look over at problem number 8, we do keep it just as is because our variable is on the left side of the inequality. First thing that we're going to do is get rid of that -13. The inverse operation to that is to add 13 to both sides. We're going to add 13 to both sides. That -2x now comes down as a -2x. So we get -2x is less than or equal to 24. So please be mindful of that minus sign belongs to the 2x, not to the -13. Okay, so that minus sign does come down, which does happen to have an effect because now we happen to be dividing both sides by a negative. So since we're going to be dividing by a negative, that means we are going to have to go ahead and flip our inequality. It becomes a greater than or equal to inequality. So we get x is greater than or equal to -12. Okay, our last problem, we have 0.6x plus 8 is less than 23. There is no need to do any kind of rewrite, so we can keep it as it is. We're going to subtract 8 from both sides first. Okay, that's going to leave us with 0.6x is now less than 15. And then we are going to divide both sides by 0.6. Okay, we do happen to be dividing both sides by a positive, which means we're going to go ahead and keep our inequality just as it is. Okay, so we get x is less than 25. Okay, any questions on solving our inequalities? Again, you do addition and subtraction first, multiplication and division second, Multiplication and division is the only one that could potentially change your inequality's direction. So be mindful of those. All right, let's go ahead and flip it on over to some of the word problems. Okay, so for problem number 10, it says the quotient of a number and -8 is at most -6. The quotient of a number and -8 is at most -6. Who can remind us again, what does quotient mean? What operation was quotient? Jalen? Division. So when we talked about quotient, the term quotient means that we will be setting up a division problem. So we're taking a number, x, well, I'll use my variable. We're taking our number x, we're going to divide it by a -8, so x divided by -8, and then is at most. Is at most. What inequality symbol represents is at most? Mason? Less than or equal to. Is at most -6 means that's the highest it could potentially be. It is going to be less than or equal to -6. Is at most is a less than or equal to -6. And then we could go about solving it. Now I could rewrite x divided by -8. I could rewrite it in a fashion that you guys are more comfortable with. X over -8 less than or equal to -6. And then I can go ahead and solve that eventually. But I'm not going to worry about solving right now. I'm just worrying about translating these into their word formats. Number 11, twice a number is at least -10. Twice a number is at least -10. What does twice a number represent? What operation is twice? Io? And what are we specifically multiplying by? If we say twice, what value are we multiplying by? Huh? What value is twice? What number is twice? 2. So we're multiplying by 2. So twice a number means it's going to be 2 times a number. Is at least, if I say it is at least -10, what inequality is going to be at least? Is it less than, greater than, less than or equal to, greater than or equal to? Mason? Greater than or equal to. Okay, greater than or equal to -10. There's our inequality. 2x is greater than or equal to -10. And then eventually we could solve if needed. Okay? All right. Let's take a look at problem number 12. Kim is reading a book. She wants to read a minimum of 150 pages by the end of the week. So far, she's read 20 pages. If there are 5 more days left, we want to write, solve, and graph an inequality that will represent the number of pages that she needs to read each day in order to meet her goal. Okay, so think of it in terms of if it was an equation, what would we be setting the equation equal to? What number up here would we be setting it equal to? Read through. Kim's reading a book. She wants to read a minimum of 150 pages by the end of the week. She's read 20 pages so far. She's got 5 more days left to read. Which one of those values is her end value? What we want it to equal? 150. Right? But in this case, it's a minimum of 150. So we need to understand what minimum represents. What inequality is minimum? Turn and talk to your partners. Turn and talk to a neighbor. Tell them what you think minimum is. Is it greater than, less than, greater than or equal to, less than or equal to? What does minimum mean? All right, what do we get? Madison? Huh? So a minimum of this amount. A minimum. You need a minimum of 70 to pass the class. a minimum. So that means that you can do less than 70 to pass the class? Minimum means that it has to be this value or more. Okay? Remember, it has kind of an opposite effect. Yeah. Greater than or equal to. So it's going to be greater than or equal to 150. Shh. We know it's greater than or equal to 150. So now let's read the rest of the stuff. So far, she's read 20 pages. That's going to be her starting point. She has started at 20 pages already read. And then she's going to continue reading. So if she continues reading, are we adding or subtracting? Adding. Then she's going to read for 5 more days. And she's going to read a certain amount every day for 5 more days. So that means she's going to read P amount of pages every day consistently for 5 days straight. So that's 5 times P. So there's our inequality. If you were to solve it, so I'm not gonna worry about solving right now because we've already done a whole bunch of the solving. If we were to solve it, then we would get that the amount of pages is going to be greater than or equal to 26 pages a day. She needs to read 26 pages or more a day in order to meet her goal. Okay, if she reads exactly 26 pages every single day, she will meet her goal at 5 days. If she reads more than that, then she'd probably meet it in less than 5 days. Okay, now if we were to graph that, it would be a closed circle, and it would be going to the right. All right, let's take a look at problem number 13. For Halloween, I want to give at least 48 goodie bags to trick-or-treaters. My daughter and her 9 friends will get a goodie bag as well. We're going to write, solve, and graph each inequality that shows how many trick-or-treaters I need to have to come to my house. Okay, so I want to make at least 48 goodie bags. Remember, the term at least means greater than or equal. So we want greater than or equal to 48. Now, I also know that my daughter and her 9 friends are going to be getting a goodie bag as well. So I have my daughter and her 9 friends are going to be a part of getting that goodie bag. Okay, so how many people is that so far? 10 people, right? So I know I'm starting off with 10 people who are going to receive the goodie bag. I want to know how many more trick-or-treaters do I need in order to meet my goal of at least 48 bags. So that's going to be plus X. Okay, sometimes it might just be a 1-step or a 2-step, but then you don't know which one it's going to be. So we have 10 plus X is greater than or equal to 48. Isaiah, head up. Thank you. Okay, once it is solved, again, I'm not focusing on the solving part for you guys, that you should be able to follow along with what that is. We would have subtracted 10 from both sides and get that we need to have X being greater than or equal to 38. So we need at least 38 other trick-or-treaters coming to the house in order for me to have met my goal or more. And that is going to be a closed circle, and it's going to be graphing to the right. Okay, for problem number 14, I want you guys to go ahead and, actually for number 4, no, just do number 14. Do number 14 on your own. I want you to write the inequality and solve the inequality. Write, solve, and then indicate open or closed to the left or to the right. Okay, a gift card has $250 on it. I want to buy a pair of boots for $100, and there are also some scarves that cost $30 each. So we're going to go ahead and write the inequality that represents the most scarves I can buy. So remember, the most, so that's like at most. The most you can buy, or at most, would be a less than or equal to. So we know that we're spending less than or equal to $250 from the gift card, right? That's the amount of money that we're going to be able to spend. Okay, I know that I'm definitely buying a pair of boots for $100. That's part of the purchase. I'm also going to go ahead and buy the scarves that are $30 each. Remember that keyword each represents it as an operation for multiplication. So we're going to have that as X. So X plus 30, or sorry, 100 plus 30X is less than or equal to 250. If you were to have solved it correctly, when you solve it, you would get that you would have to spend or purchase 5 or less. X is less than or equal to 5. It's going to be a closed circle, and it's going to graph it to the left. X is less than or equal to 5, closed circle, graphing to the left. All right, let's go ahead and flip it on over to the last page. So with inequalities, sometimes if you get a decimal, that allows you to understand how you're going to round, how you would properly round in a situation. So for here, the most canned food Miss French-Zheng's class has ever donated is 378 cans. This year, her homeroom wants to break the record. If we talk about breaking the record, are we talking about less than the record, equal to the record, or greater than the record? Greater, right? It's not going to be equal. Okay, if it's equal to 378, did you break a record? No, you tied the record. If we want to break a record, when you break a record, that means you are going to be greater than that 378 cans. Okay, now, she's already donated 102 cans, so we know we're starting off with 102 cans that have already been donated. And then there are 22 students that are in the class, and we want them to bring cans in. So that means that's 22C. Okay, 22 students times the number of cans that each student could possibly bring in order to create a value that is greater than 378. Now, if we solve this, if we go, okay, I'm going to subtract 102 from both sides, and then I'm going to divide by 22 on both sides, I'm going to wind up getting that C is greater than 12.54. Can we bring in 12.54 and it's going to keep going number of cans? No. So that inequality is telling you the direction that you're going to round. It's telling you that you're going to round up or down. Up. You're not even focusing on the fact that it's 5.4. Who cares that it's 5.4? It could say 12.01. If this 12.01, you would still be rounding up. Because would 12 cans be enough? No. So what's the next number up from 12? 13. So they need to have greater than or equal to 13 cans. 13 cans is going to be the minimum amount that they could potentially have. 13 cans would be the minimum amount that they could potentially have. Okay? For problem number 16, I want you guys to go ahead and write the inequality and then properly round the inequality. Okay, let's take a look here. This table reflects the prices that it costs to enter the Georgia State Fair and then to the rides. So if you are going on a Monday through a Thursday, it's going to be $1.25 per ride. Friday through Sunday is going to be $1.50 per ride, and then admission, no matter what day that you're going, is going to be $15. So you have to pay to get into the fair, and then you have to pay additional prices for each of the rides that you want to ride, and depending on the day that you're going to go will depend on the price for the rides. So Janet's mom gave her $40 to spend at her friend's birthday party on Friday night at the fair. So it's a Friday night that they're going to the fair, and she's got $40 that she's allowed to spend. Can she spend more than $40? No. Can she spend exactly $40? Yeah. Could she spend less than $40? Yeah. So we know that this is going to be a less than or equal to $40 for her. Okay? She can spend $40. At the most that she'll be able to spend is going to be $40. She is going on a Friday night, which means that the price per ride is going to be $1.50 per ride. I should have done that in green, but here, we'll do that in green now. $1.50 per ride. So we have $1.50 per ride, so I'm going to put per R. Plus, she also has to pay for her admission. So she's got to pay to be able to get into the fair. So $15 just to get in. Okay, when we start solving this, it's going to solve out to where R is less than or equal to 16.6 repeated for the number of rides that she can ride. Again, can she ride 16.6 rides? No. You ride a ride or you don't ride the ride. It's a whole number value. So what are we going to round 16 to? Wrong. 15. Or, not 15, 16. You're going to round it down to 16. Okay? Not 17. Yes, I know 16.6 would normally go to 17, but it says it has to be less or equal to that value. Less or equal to 16.6. 17 is not less or equal to 16.6. You have to go below that value. So we're going to estimate it down. Less than or equal to 16 rides. So 16 rides is the most that she's going to be able to ride to still be able to stay at $40 or less. Okay? All right. What you are going to do now, you're just going to be practicing solving inequalities today. We're not going to really focus on the translating yet. You're going to practice solving inequalities today. Loaded in Google Classroom, you have 2 IXL skills. Be careful about the switch up. If you have to flip the inequality, that's because you're multiplying or dividing by a negative. Be careful about that.